So we saw that if something is a repeating decimal, then we can write it as a ratio of two integers. In other words, it's a rational number. But how do you do that? Let's look at an example. So let's suppose that we have this repeating decimal. X is equal to 8.5323232323232, and so on and so on. Okay. So we're going to look at a little bit of a trick here, and you probably wouldn't know to do this if you hadn't seen it already. But once you see it, then you realize how it works. So here's what we're going to do. We're going to take x and we're going to multiply it by 1,000. So that moves the decimal point over. If we multiply by 1,000, now we have 8,532.323232323232. And now I'm going to look at 10x. That again would move the decimal point. So we have 85.3232323232, and so on. And now I'm going to look at 1,000x, and I'm going to subtract the 10x. And when you do that, something nice happens. All the 32323232s that are at the end there, they kind of go away. So we'd get 990x on the left. That's 1,000 minus 10. And then with the x, and that equals 8,532 minus 85, and then all that other junk on the end just disappears. And this is nice because now to get x by itself, we can just divide both sides by 990, and we would get x is equal to 8,447 divided by 990. And that is a rational number. It's the ratio of two integers. Okay, so this is great, but let's look at another example. How about x is equal to 0.8888888888888? Well, 100 times that would be 88.88888888, and then 10 times that would be 8.88888888. If we subtract them, all the junk at the end goes away, and we would get 90x on the left and 80 on the right. And so x would be 80 divided by 90, which is the same thing as 8/9. Now you might wonder, how did I know to multiply by 100 and then to multiply by 10? In the previous example, I multiplied by 1,000 and then I multiplied by 10. It seems kind of arbitrary. Well, it is a little bit arbitrary. There are different ways to do it. You just need to make sure that you get something that's going to cancel all the stuff at the end. And if that means you have to try different multiples, that's fine. But I'll show you that there's no one right way to do it. Here's another way. Suppose I have 10x, that's 8.8888888. And then I have just plain old x, that's 0.8888888. Subtract, I get 9x equals 8, and x equals 8/9. You get the same answer either way.